Welcome all back. Welcome to the second panel of the Climate Science from Space, Synergies for a Greener Innovation Economy. In this panel, we want to approach the roadmap for a digital and greener Earth and how to upscale solutions that trigger transformation. Our first speaker is Joana Mendonça. She's the Director International Promotion from Agência, Nacional, Inovação. Joana is also an Associate Professor at the Engineering and Management Department at Instituto Superior Técnico, where she teaches innovation management and design thinking, entrepreneurship, economic engineering, and project subjects. Oh God, so many things. Welcome, Professor Joana.
Thank you. Thank you for that introduction and that's your kind invitation to participate in this panel. It's an honor to speak before this quite wide and varied panel that we have today, and to speak about the roadmap for digital and a greener Earth, and talking about the goal of upscaling solutions that trigger that transformation. In fact, when we think of innovation and the greatest innovations, they come precisely from putting together knowledge and applications from different fields, and the space systems really have a role in developing and or promoting the development of innovation and solutions that may contribute for a greener world. I mean, certainly climate change is one of our main threats to our planet and our society, and there's an urgent need now, and there has been for quite a number of years that calls for action from many countries, many governments and individuals. And even though we are currently facing quite a large challenge with the COVID-19 pandemic, this actually just increases the concern for climate action. So it's in this context, of course, Europe has been leading the way in contributing for a greener world, a greener economy, and we believe that this path will continue. And in this context, of course, the von der Leyen policy priorities have been setting the goal for Europe to become the first climate neutral continent by 2050. And of course, it's in this context that a set of new policies have been developed, including, of course, the European Green Deal, and also the Europe Fit for the Digital Age. And these may be the driving forces of this paradigm shift that we hope to witness in the years to come. With the European Green Deal, the Commission commits to climate transition. This will require substantial efforts in many areas, but certainly in research and innovation. And this is why I am speaking here today about how innovation can contribute to this paradigm shift. And of course, the digital twin Earth concept that is emerging in Europe may represent a very relevant and important objective towards this transition to a green digital society in Europe, promoting economic resilience and independence, technological dependence from other regions, and to promote industry across Europe. We hope that these policies may have a role in contributing to this paradigm shift and to allow the development and production and commercialization and upscaling solutions that may come. I'm sure the panelists in this panel will give very relevant and important examples. And in this process of this climate transition, of course, space technologies might have a relevant role, and that is why we are these 2 days discussing this potential role. We know space systems are critical to feed information that can be used, and that may allow for the development of new products and services, and certainly help build new business models based on this knowledge and information, specifically with Earth observation that may contribute to this climate action and allow for a greater innovation. This includes, for sure, monitoring CO2, for instance, to protect citizens' health, but also addressing a wide variety of parameters that can be based on space observation and Earth observation. Now, the Innovation Agency, ANI, in Portugal, aims at promoting innovation with the critical mission support business and technological innovation, bringing together different actors of the so-called innovation system, innovation space, companies, startups, technological centers, universities, and bringing together these different institutions to get knowledge together and to allow for the development of complex and critical solutions. So just to tell you a bit on how the Innovation Agency plays a role in this relationship between the application of space solutions and space technologies as a potential contribute for a greener economy. Naturally, to follow this mission, the Innovation Agency plays a role in promoting innovation, to enable these different applications, and also fund research at lower TRLs, lower development levels that might fulfill these European goals and this vision for a greener Earth. And this is the role of the Innovation Agency. Of course, more on an operative way, the Innovation Agency includes the Horizon 2020 national contact points and delegates, and puts this synergetic approach, and also the programs within the European Union. Just a few numbers, just to give you an idea of how the Innovation Agency has been funding and supporting some activities that might be integrated in this combined effort. Looking together at considering the climate action and space sectors, Portugal's participation in Horizon 2020 has led to a total of 145 participations in projects. 19 of these projects are already coordinated by Portugal. These, of course, are considering different actions, both in climate and in space. Naturally, what we are looking to do in these 2 days is how these can be combined in such a way. How can the space solutions be part of a solution or the climate action? And so just that this can be the base of the development of further innovation and further projects, both at the national and European level. In fact, just looking at national funding, we have a total of 19 million that have been funded to, again, research and innovation, both in climate action and in the space sectors. I'm sure Ricardo will then tell you a bit a broader view in terms of what the space sector in Portugal is. These numbers just are given as an example to highlight the importance, the critical importance of research and innovation in this paradigm shift of promotion towards a carbon neutral society and achieving the goal, the European goal, as has been set by the European Commission. Just another example is that the a bit larger scale projects that have been set to promote actually collaborative innovation in the value chains of the space and climate sectors. There's 2 large projects in Portugal worth mention. One is Infrequent. I don't know if this will be addressed further with more detail, which is a project that aims at developing the first Portuguese satellite. The ESA-DEVELOPED project that addresses Atlantic sustainability through integrated solutions And this can provide already some technical and knowledge development for precisely the design and implementation of applications to exploit the sea economy, and that will have greater value to this common goal. In addition to that, of course, in a wide variety of programs, the Innovation Agency funds not just these actions and programs, but also certain institutions, knowledge and technological transfer institutions that may be critical into linking knowledge to the market solutions by bringing together higher education institutions and companies. And these are the so-called technological interfaces centers and the collaborative laboratories. In fact, there is already at least one relevant collaborative laboratory that actually already establishes this relationship from climate science from a space perspective, which is the plus Atlantic. This is just an example that is a base on which we can build upon. So there's already some knowledge integrating firms, technological interfaces and institutions, and research institutions that can really bring knowledge and apply it to leading for new solutions and new business models to the market. So thank you so much for this kind invitation, and I'm really looking forward to hear what my colleagues in the panel have to say.
Thank you so much.
I have 15 seconds.
Thank you so much, Joana, for your contribution to telling us what you've been doing and the projects that you are involved. Now it's time to talk with Jessika Trancik. Jessika Trancik is an associate professor in the Institute for Data, Systems and Society at the Massachusetts Institute of Technology, known as MIT. Her research examines and explains the dynamic costs and environmental impacts of energy technologies to inform climate policy and technology development. Hello, Jessika.
Hello, how are you?
Welcome. Fine.
Thank you. Thank you. Great. Well, thank you. It's great to have the opportunity to speak with you today to our digital audience, and I'll be giving a short research talk, but it's really about how research can inform action. And I would like to acknowledge the MIT Portugal program, which is an important source of collaboration with Portugal and a source of funding for several of the topics I will touch on today. For those that are not aware, the MIT Portugal program focuses on 4 strategic areas: climate science and earth systems, oceans to near space, digital manufacturing, and sustainable cities. And today I'm going to be speaking about how we can use data to inform clean energy and climate solutions and accelerate some of the innovation that is still needed in order to rapidly draw down greenhouse gas emissions and thereby address climate change. So let me just quickly start by recognizing the climate risks that are a reality today. For example, we see fires, droughts, severe storms, extreme flooding, erosion, and other reasons that other sort of displacement related impacts. And governments and companies are getting serious about addressing these risks. Here I'm showing an image taken after the Paris Global agreement was reached in 2015, the climate agreement, and more recently there have been a slew of major announcements, for example, by automakers who are planning to phase out petrol and diesel-based cars within a couple of decades, and many companies are really beginning to get serious about addressing climate change, and some are already doing a lot. But to meet global climate targets that have been set with an aim of averting the most devastating impacts of climate change, economies must change very quickly to reduce emissions following a scenario like this one, which is based on a 2 degrees Celsius temperature target, or even a more aggressive one like this one, which is, of course, based on the 1.5 degrees Celsius temperature target. And the different lines in these plots indicate the rates of change needed depending on when the declines begin. And as was mentioned, in some nations, emissions reductions are advancing faster. Europe is a standout example in this case. But much more is needed. So many of the technologies are already available today that can transition the economy away from fossil fuels. But an economy-wide change still requires advancement on multiple fronts. That's in hardware technology, business models, and a range of institutions and software, et cetera. And so when I talk about technology, I'm using a very broad definition that encompasses those different kinds of technologies: hardware, business models, software, other kinds of standardized practices. And to stretch government funds further, it's important to be deliberate about how funds and time are invested in developing clean energy solutions. So that's really where these data-informed models can help. And my work is all about enabling us as a society to be more deliberate about technology through the use of data-informed models. And I would like to give you some examples of what is possible to do and how research can support climate action. So just a quick overview of the objective of the research we do in my group and with collaborators around the world, including in Portugal, is to accelerate progress using data-informed models that help us understand and shape technological adoption and innovation in order to accelerate equitable climate solutions. So we use database models to learn about how technologies evolve and how to best advance them to meet societal goals. Essentially, what we want to do is use the data and use the models to be able to do more per dollar invested and to make faster progress. And this means that we need to understand the positive feedback loop that climate policy and technology innovation can form. So we can see this in the case of solar energy, which is discussed in this graph, for example, where policies stimulated markets and research activities, technologies improved, and costs fell by 99% over a few decades. And this is now enabling further emissions cuts. And in my group, we work on understanding these virtuous cycles and how one can deliberately support them through good decisions. Our approach is to data and technological innovation, understand its drivers, and identify targets. And the definition of technology, again, is very broad. It applies across scales, from materials to devices to infrastructures. Technology includes hardware and soft technology, and soft technology, examples of which are software and business. And the results of work give us new fundamental understanding of and what makes it evolve, and also allows us to estimate targets that collective innovation processes can work towards, so many people in society. Through these methodological approaches that we're advancing, we can be more specific about the key interventions that would make a difference and how to measure progress along the way. So this is really critical. It's, climate policy is not just about setting targets, but it's also about the path to getting there and supporting that path, which is what our research aims to do. Two technologies that we have examined are solar energy, which fell in cost by 99% over the last 4 decades, and lithium-ion battery technologies that fell in cost by 97% over the past 3 decades. So these are really impressive cost declines, and they represent many innovations done by many different people. And we've developed approaches that allow us to understand what led to these cost declines so that we can inform decisions at different levels, at the level of government policy, at the level of private investing, and at the level of engineering. So this is just a quick picture of what these approaches look like that we've developed to understand the drivers of these processes. For solar energy, for example, we learned that market expansion policies like the solar feed-in tariff in Germany and several policies in Portugal as well and other EU countries were essential for driving the cost decline. And we estimate that 60% of that 99% cost decline I mentioned before came from this category of policies, the market expansion policies, and about 30% from government funding for research globally. And so this gives a picture of how such virtuous cycles could be set up for other technologies. The processes would have to be specific to the technologies, but the overall process is one that I believe can be replicated. And a version of this also explains what happened to lithium-ion battery technologies. As another example of work we do, we estimate quantitative targets that people can work towards in order to make a major impact on the system. So you have a lot of people, for example, working on low-cost stationary energy storage in order to support the continued growth of renewable energy. What are the cost targets that we should be aiming for in order to help bring about systemic change? Here, the approach that needs to be taken is to examine massive data sets on the variability in solar and wind energy resources, satellite data on land constraints, and so forth, and build a model of the power grid. And from this work, one of the interesting insights and very important ones is that we learned that the events that define the storage cost targets and the storage sites needed are certain relatively rare events where solar and wind resources remain at below average levels for longer periods of time. Now, these events can be addressed with energy storage or with demand management or to some extent transmission infrastructure expansion. But really understanding these events and the cost targets are important for informing all of those innovation efforts. And we're currently investigating the nature of these events, what was behind these deep state of charge declines in the simulated system. We're doing this investigation with several colleagues from a couple of different Portuguese universities. And the targets that we estimate for storage cost declines depend on the percentage of electricity coming from variable renewable energy, of course. And these cost declines range from costs that are, the cost targets range from costs that are close to those of lithium-ion batteries today, all the way, if we're really wanting to rely on a 100% renewable system, mainly balancing out renewable energy with storage, then we would like to see a 90% drop in storage costs to reach a target of about $20 per kilowatt hour for installed storage capacity. In another example, we examine targets at the infrastructure level. Here, we're looking at how people move around in cars in order to determine where electric vehicle chargers should be located to match people's behaviors so that they can conveniently and predictably charge. And this can support the rapid scaling up of electric vehicles of different types and also help draw down emissions very rapidly. And again, interestingly, we find that certain rare but large events define where these infrastructures really need to be placed. Defined not only by regular travel days, but also what we call the high energy days. And that must be taken in infrastructure. So that's what we can see with solutions that are shown here. And in this analysis, we consider how people naturally move around in cars, which varies from person to person, and where they stop, for how long they stop. So a lot of different variations that capture different patterns that people may have. And the idea is, again, to guide policy as well as private sector innovation for this important infrastructure. And this leads us to conclude a very actionable conclusion, which is that for many locations, there are 4 priority areas or 4 priority locations for chargers shown in the bottom row of this graph. That's charging, whether it's public or private, for when people are parked at home. That's essential, and these chargers don't need to be the more expensive fast chargers. And charging at work, since it helps the power grid, that's the second priority. Overnight public charging at locations like hotels, and fast charging on highways or where people travel far on rural roads. These are research results, but they can inform decisions by engineers, private investors, policymakers, and the public, which is a key objective of my research. I want to find the levers that many different people across society can use to make a difference and help address climate change. And in this way, we work to use research to inform action. So, for example, the storage cost targets, as I mentioned, can inform lots of efforts to improve energy storage across startups and more mature companies and through government research programs. The trends in technology informs private investing. Knowledge of the determinants of technology change informs policymaking. For example, in the Obama administration press release on the Paris Agreement shown here, they referred to the mutually reinforcing cycle we had uncovered and documented, in which enhanced mitigation increases investment and enhanced investment allows additional mitigation by driving down costs. And we had characterized the strength of those feedbacks. And these data also inform models that, or these data-informed models rather also inform public decision-making. So for example, through my team's app, which is called carboncounter.com, which was recently featured in the New York Times, which is shown here, it has been taken up by many different people to help inform their decisions about car purchases. I know that because I receive emails from people around the world that are using the app, and it's a great way to get feedback also on the research and what people are interested in. So just to conclude, the bottom line is that I believe, it's really important to be more deliberate about technology. This is important in order to be able to do more with less. We have limited time to address climate change, and there's always limited funding. Data-informed models, such as the example that the few examples I shared today, can guide decisions for faster progress and to arrive at technology solutions that are more beneficial to society. Thank you very much.
Thank you so much. I could not agree more with you. What a valuable research. Congratulations. Next speaker, it's another Portuguese. Ricardo Conde is president of the Portuguese Space Agency. He holds a degree in electrical and computer engineering from Technical University of Lisbon and a postgraduate degree in space technologies. He began his professional career in 1991, having been linked to the aeronautics and space sector since 1993, with a participation in several national and international programs, in particular in space and Earth segments. A great responsibility. Ricardo, what can space do for us and what can we do from space?
Hello, good afternoon. Good afternoon, everyone, and my colleagues of the panel. And first of all, thank you for the invitation. The topic that for the discussion here today is really relevant, and more it is urgent to address all these discussions in all the corners, in all the opportunities that we have. We are living today a dramatic moment in our lives because, of course, the tragedy of the pandemic that we are facing now. But I think this brought to us the new conscience about how fragile we are, right? We are really spending many decades with the same economic model and based in the extractions of the resources of the planet, the resources that the planet doesn't have. And our economic model is based in the constant growth, which is a contradiction, means at the end to increase the problem of sustainability in our relation with the planet. But this pandemic moment gave to us, I believe, more conscient attitudes, and particularly some kind of international collaboration fight this pandemic. This is something the good results of at the end, if there are any, of the pandemic that we are living. But we are now living another dramatic moment, which is the climate change. It is not a thing that appears immediately, but slowly, day by day, year by year, and is giving the impression that we have all the time to solve the problems that we are facing now and will face in the near future, and is giving the impression that we'll have time to implement the measures to mitigate or even to revert the situation. I think we are living in a corner of the dramatic situation with the global implications, even putting cause our existence, right? I think this is the message here. But there are some perspectives. It's curious because there are some perspectives saying that at the end of this century, the climate change will be responsible to reduce the world economic growth in 20%. This is something that will be a dramatic consequences in the big social impact that this represents. And we don't have time, and we need to act immediately. We need to act now, and for that, international collaboration is needed, and is the moment to get some answers from the science. And I really like the previous presentation about how science can tackle several dimensions in what we can do. But one of the dimensions that we can follow is to better understand the dynamics of the climate change and the interactions between the atmosphere and the oceans. And I mean more knowledge and more science. We need more knowledge and more science in these interactions. And for that, it is important to have access to Earth observation data. This is one of the points that we are also addressing here in our discussion. Today, we already have some tools. For example, fast computing and processing the big amount of data that we are having nowadays. I mean, Earth observation data. And we have also new technologies for fast communications, the 5G, for example, to transfer amount of data in the near real time, almost real time. And we have also tools for analytics to extract this information, like artificial intelligence, machine learning. So we have all these tools. So what we need more? I think we need to get more and more data to feed the predicting models, and naturally satellite Earth observation data is needed. But we need more quality data and space and time resolution data to feed our models. For that, it is really important to reduce the barriers that to access this data, and also to create and launch new sensors, new satellites, new constellations to feed these models. I think it is important and urgent to promote the idea of open data. I think this is the solution to tackle the problems of developed downstream applications, and to feed, as I said, the predicting models and get more knowledge, particularly in these interactions between the oceans, atmospheres, climate change, at least to try to mitigate the impacts that the climate change will have in the way we live today. I think this will help also us to define a new path for the economic models, more sustainable economic models that we need. And of course, with some equilibrium that we need between the nature and us. And I think Earth observation data is not anymore a question of markets and sovereignty. I think Earth observation data is now a question of surviving, let's say like this, because we need for that global coordination to implement open data policies. And the climate change, there are no borders for the climate change. So it's a worldwide problem, and we are running now the initiatives for example, in Europe, as you said before, the digital twin huts. This is initiatives to combining past, present, and future predicting models, and this is a giant step. But again, we need to go deeper, particularly to obtain more data, more quality data, and as I said before, to use time and space resolution data to have almost near real-time scenario about our planet. And we have only one planet, and I will invoke the words of the United Nations Secretary General, António Guterres, said that there is no planet B. So I think the policies to coordinate Earth observation data and put the data available to our community to better understand interactions, I think is a question of surviving. So I will finish my presentation here. I'm available to cross my thoughts also with my colleagues and the audience. Thank you.
Thank you so much, Ricardo. I use this experience and also what you said to remember all the audience that in the chat they can write their questions to write also some doubts that they have and that they want to see answered by our speakers. So use it. It's the best way to interact and to dialogue with this exquisite professionals, investigators, investors, and researchers. If you have something to say, something to answer, use it. This is your time. This is your chance. Therefore, we have to follow our timetable, our schedule. I invite Isabel Trigo to join us. She's the coordinator of Earth Observation Units at the Portuguese National Meteorological Service. She has followed a research career in meteorology and climatology for more than 20 years, working on climate variability, land atmosphere interactions and applications of remote sensing observations to characterize and monitor land surfaces. She is the scientific coordinator for the UMSAT Satellite Applications Facility on land surface analysis and the coordinator of IPMAS, or I'll tell you what it is, Earth Observation Units. Hello, your vision, most of your lifetime is up on the Earth, right? Isabel.
Hello, good afternoon. Well, thank you very much for this introduction. And thank you for giving me the opportunity to share some thoughts and examples on the use of satellite observations to monitor land surfaces. And monitor land surfaces now having our mind on climate change. This is long-term assessment of changes and trends. And to put a historical perspective here, I remind you that the first weather satellite was launched, the European weather satellite was launched still in the 1970s. The fact is that although it's very hard, it's still not straightforward to use those very early observations. We do have more than 40 years of data that can be very useful to assess climate and climate variability. And if we think of other Earth observation missions, we have data over 15, 20, 30 years that can indeed be very useful. This slide that you are seeing there gives a glimpse of ESA Earth observation missions, but it is actually very outdated. If we look at the current and future ESA missions that are planned within the Copernicus Sentinel program, or weather satellites to be co-developed and operated by EUMETSAT, you see that we have a huge range and diversity of types of observations, and most importantly, I want to stress this, that will be here for several decades to come. So giving this long-term perspective that is essential when we talk about climate and climate variability. So we do have these regular satellite observations in space and time, covering wide areas from regional to global to continental scales over very long periods, with a diversity of sensors and types of observations. And we can use these to derive essential climate variables. I think these have already been mentioned before by Suzanne. These essential climate variables allow us to monitor the state of our climate system and to monitor its evolution, and the evolution of its components being the atmosphere, the oceans, the cryosphere, and of course the land surfaces. So let me share with you a little bit the experience that we have within the Landsat, that is indeed a decentralized satellite application facility of EUMETSAT that is being operated here in Lisbon at IPMA, where we have been committed to derive climate data records of variables relevant to monitor land surfaces that together can be seen as data cubes. This is a range of variables that can give us different perspectives of how the surfaces are evolving in time. The examples that you have there are variables derived from a series of satellites, the Meteosat second generation satellites. These are geostationary satellites, therefore they cover a limited area over the globe, but we are deriving these variables in a consistent way. We have variables related to wildfires, identifying the fires and characterizing their intensity. We are deriving variables that allow us to classify the state of vegetation and to monitor the state of vegetation. We have surface radiation at the surface, long wave and solar radiation as well, land surface temperature, and many others. And this area that you see there, although it does not cover the whole globe, it does cover important climate spots. These is areas that are very sensitive to climate change. And I'm thinking of Southern Europe, the whole Mediterranean region indeed, and also Africa, from the Sahel to the Horn of Africa. These are indeed climate hotspots. And the important thing is that we have now a reasonable long record of observations, high spatial resolution and temporal resolution, and we are working to increase the family of these variables to do gross primary production. This is an example that I have there. These are important variables to monitor carbon uptake by the vegetation and the exchanges of water and energy between the surface and the atmosphere. So these are all relevant to monitor the state of our climate, the state of the land surfaces. And very, very soon, I would say within 1 year or so, we will have a different data cube encompassing climate data records from a polar orbiter. So let's say with a global coverage from vegetation state. Again, I'll be doing land surface temperature. Let me share with you just a very simple example of how these data can actually be used. What you see there are time series of average land surface temperature over the whole of Iberia for a period encompassing between 2004 and 2017. The top that time series is just a plain time series of land surface temperature. In the middle, you have land surface temperature anomalies. So in red, you will see months that are warmer than average. In blue, you will see months that are cooler than average. And I have highlighted there two specific ones. Those are June 2017 and October 2017. Those were record-breaking months for this time series over Iberia. So these are the warmest June and the warmest October. And actually, the Portuguese remember these months sadly because in that time, we had these major fires over Portugal that unfortunately caused several casualties. It's not surprising. So this very high fire activity would also show in our data records of fire radiative power. And of course, temperature, fire activity, vegetation, these are all interlinked. The lower panel, so the lower time series, are anomalies of fraction of vegetation cover in green, above average vegetation growth, and in yellow, brownish, below average. And I've highlighted there the major droughts in Iberia that are clearly visible in this time series. 2005, so a year with higher than average fire activity, 2012 and 2017, which I have already mentioned. So what are the main challenges to use these Earth observation data and Earth observation products for climate applications? Well, to isolate seasonal features such as those that I have just shown before and to identify climate change and climate trends, we do need to quantify very clearly the uncertainty of this data. These have been mentioned before in previous talks. Indeed, we have to ensure and convey confidence that the signal that we are measuring is higher, is stronger than the uncertainty. So that's very important that we ensure high quality data, that we have stability in our data records, that we ensure a smooth transition among different sensors and different satellites. And of course, that is not all. We have to ensure that we do our job properly, that we do a very careful validation of our data against reference observations, in situ observations. Within the Landsaf, we do maintain a few in situ, so ground stations, but we do validate this data with networks that are available to the community. And when we think of the future, so how should we do this? How should we plan our future developments and services? We have to keep in mind current missions, future missions, and ensure consistency among data sets, among the different variables that we are deriving, ensure service continuity of near real-time production and of climate data records that need to be continuously updated, and to ensure very long time series of products. And this is a huge effort that has to be coordinated among all the players that are working in these fields. And I'm thinking in particular the SAFs of the EUMETSAT network, ESA through the Climate Change Initiative, which we are working with, and the Copernicus services, Global Land, Atmospheric Monitoring, and Climate Service. So this is basically what I had to share with you. If you can, I would invite you to learn more about the work that we are doing to monitor land surfaces within the Landsat that I mentioned here, but also the climate change initiative on land surface temperature. Thank you very much.
Thank you, Isabel. Thank you very much. I'll remind once again the audience that they can use the chat to write some questions. So all the doubts you have, expose them there, because our speakers will be here after the presentations to take all the doubts and to answer the questions you write on the chat. So keep going. Now it's time to hear Gregory Jenkins. He's currently a professor in the Department of Meteorology at Penn State University and Director of the Alliance for Education, Sciences, Engineering and Development in Africa in the College of Earth and Mineral Sciences. He received his MS and PhD degrees in atmospheric and space sciences from the University of Michigan. Dr. Jenkins has taken part in NASA African Monsoon Disciplinary Analysis Field Campaign in Cape Verde and Senegal. And his areas of research are in the weather, climate and air quality of West Africa. Welcome, Dr. Jenkins. You have to turn on your microphone. We can hear you.
Oh, thank you.
No.
I said I thought I was losing some internet connectivity. I'd like to thank you for inviting me, and I'm very happy to be on the panel with Miguel, my friend, who's the CEO of the Air Center. This is a very important topic that is being discussed. And in addition to the upscaling of data and technology, we also need to upscale knowledge and awareness and human capacity to address the climate crisis. And the Spaceborne platform is a very important platform to connect climate sciences to the Earth observations. So this first slide kind of gives a story to the public, which during the daytime, you see the beautiful blue marble. But during the evening, we can see industrializations and potential sources of emissions. And we can also see rapid urbanization, which again might imply that there are lots of transportation sources which are responsible for carbon emissions. But we really need the observations from space to see the planet holistically as it's changing. And that, includes rising sea level or the loss of ice from the polar regions and the productivity from the ocean and the vegetation on the ground as it relates to land masses. Without that, we can't have a holistic view. And the public needs a holistic view as population is increasing and as warming is occurring. So this is just kind of the NASA view of the changing planet. And, it's very important that the public is aware of what is happening from space. But we also need this data to help us to evaluate projections. And those projections will depend on what we're doing in each of our countries and on the planet as a whole. we know that the future has issues as it relates to food security. So we need to be monitoring the oceans very carefully because in the next few decades, big changes may be happening. Those communities, those fishing communities and those fishing industries, and in general, the governments have to be aware of changes in food security as it relates to the oceans. The same will be true for land areas. And kind of the other part of this are the hazards. So we don't have to wait until 2050 or 2100 to know that the extremes are increasing. And individuals at all scales, whether they're in cities or they're in rural zones, they know that something is happening. So the spaceborne observations can tell us that. It can tell us that in near real time. That can be conveyed to the public. And you know, we can see, for example, in one of these figures over the US, we had massive amounts of wildfires, and we also had tropical cyclones at the same time. But what the picture doesn't really tell us is about how air quality was being impacted, or you know, people in general as they had to flee from the fires. So there's a health component that's often embedded in the spaceborne observations, and they're happening on the ground in real time. The picture here is from the lower picture is from earlier this year. Large dust event. The models were forecasting it. Of course, most people on the ground know this was an inevitable event that was bearing down on most of West Africa, literally tens of millions of people. But when it arrived, it was a question of what is happening. So my colleagues and friends in West Africa were sending me emails and sending me WhatsApp messages of the evolution that happened between night and morning. And these are the kinds of products that observations can help us to address before the events happen, so that people on the ground are ready. And we know, for example, that air pollution, whether it's natural or anthropogenic, is responsible for a number of premature deaths in Africa. And I just want to finish this on what I feel is the most important part, that climate science and Earth observations, EO, aren't always addressing. And that is related to climate justice. So while we talk about climate sciences and climate change, what else matters is related to environmental justice and social justice. And the Biden administration, for example, has spoken about Justice 40, which helps to address inequities in communities, but also does that through, for example, the green economy, and how the green economy could help booster, you know, communities that have been left behind. What we know is that the scenario can't tell us how vulnerable will be impacted, because they're outside, in a sense, of the mainstream. In this picture, we see, for example, that Africa has the lowest income per GDP. And we know that this is tied to historical earlier events related to the export of people and products. It also has the lowest number of in situ measurements. So we don't really know what's happening on the ground in real time. Satellites are the only that we use typically, but for sure, this won't be enough during the climate crisis. And again, I say that climate justice is the intersection of these various pieces. When we talk about environmental justice, it's not really spoken that much outside of the context of the United States, but in fact, it's a global. In the United States, It's where pollution disproportionately acts as a hazard on the lives of people of color or indigenous people or poor communities. And you see in some of these pictures, like related to waste, this is a picture from the Gambia. This is where, it's in a neighborhood with 5 elementary schools, and the pollution levels are bad. And again, we think that probably up to 500,000 people die prematurely pollution. So that's a big one. And as you know, just as of yesterday, our whole community here in the US, we were really on edge about the justice issue, because quite often it isn't served. And every time justice is not served, people lose faith in governments and in each other. And when we all need to come together to fight a big problem, the climate crisis, it requires that we can talk to each other and see each other equally as humans, regardless of our income, our religion, our race, or any other difference. And if we can't do that, this climate crisis, no matter what policies you play, no matter what technologies we develop, will be a disaster for billions of people. So I just want to end there. And I really feel like the EO community and the climate science communities have a job ahead of them. They need to figure out how to more people into more people into the technologies, the development, and how these can help their communities adjust and survive during this climate crisis. That's all I have to say. And thanks for inviting me again.
Thank you so much. So very inspiring, some words that you share with us. Thank you so much, Dr. Jenkins. And now, Miguel Belo Moura, CEO of the Atlantic International Research Center, international organization to develop scientific and technological applications in the Atlantic region. Miguel has been entrepreneur in the European space sector, involved in the management of international space programs and institutions, was founder and CEO of all companies in Deimos Group in Spain, Portugal, United Kingdom, Romania and Italy. He is expert in space systems operations, space system engineering, Earth observation systems and applications, interplanetary mission design, launcher trajectory optimization and space debris. Welcome, Miguel. Thank you so much for sharing, to be with us and to share what you have to say and the contribution for this conference.
Thank you very much. Thank you very much for this presentation. Thank you for the invitation for this event. And thank you especially to the excellent presentations from Greg, Isabel, Ricardo, Jessika, and Joana. I would like to talk about the Earth Center. What is the Earth Center and what is it? Is an international tool for a greener and digital Atlantic. Okay, may I have the presentation? I think I cannot see it.
Do we have the presentation of Miguel?
Yeah, okay, it's there.
Okay.
It's there. Okay, well, the Earth Center, as you said, is an international non-profit organization to develop scientific and technological application for dealing with problems like sustainability, climate change, ocean pollution. It is targeted to create jobs in the Atlantic regions, but with a scientific base, and the main science are space, ocean, and climate. And with a special emphasis in the relation north, south, east, west along the Atlantic. The Earth Center was created as the result of a scientific diplomacy effort. Everything started in New York in 2016 in a meeting in the United Nations where several countries of the Atlantic met. And after several meetings in different continents, it ends in 2018 with the creation of the Earth Center in a meeting in Praia in Cabo Verde. And You can see there in red the countries which are already member of the Earth Center, which is in Africa, South Africa, Angola, Namibia, Nigeria, Cabo Verde, South America. In Europe, Portugal, Spain, UK, Norway, and in America is Brazil, Colombia, Mexico, United States. In yellow, the countries which are now discussing to enter into the Earth Center, basically Morocco, France, Denmark, and Canada. And we start also discussing with Argentina, Germany, and other countries. Which is the goal? The goal is to have all countries along the Atlantic as member of the Earth Center in the next year. And at Earth Center, we already got offices in all continents. We have offices in Brazil, different locations, we have offices in the States, but also in Africa. I mean that the activity that we do is distributed as a network in the different countries along the Atlantic. We have the headquarters in Azure Island, in Terceira, and we have offices in Lisbon, in the Ministry of Science and Technology. The activity that we do is divided in different lines. One of the main lines is research infrastructure. We have our headquarters in Terinov. Terinov is this technological park in Terceira Island in the Azores, and we host there an ESA lab. ESA lab is a laboratory of the European Space Agency. We have a special agreement signed between the Portuguese Space Agency, the European Space Agency, the regional government of Azure, and the Earth Center to develop application, satellite application for sustainability, for a digital and greener Atlantic. Apart from the ESA lab, we also, this is part of the infrastructure we have there. We are very proud to host the Secretariat of MBON. MBON is the Marine Biodiversity Observation Network, which holds more than 100 countries for the monitoring of biodiversity. This is also one of the missions that we have at the Earth Center. And finally, another infrastructure is we collaborate with the Geodesy international collaboration programs for very long-based interferometry with different countries along the Atlantic. This is regarding infrastructure. We are looking is to do projects, to execute project real thing. In the last year, we have presented 70 proposals for different competitive call in international framework, which is European Space Agency, Horizon 2020, now Horizon Europe for the European Union, but also in Africa and America, we are presenting proposals for activities in line with our main mission towards digital and greener Atlantic. We have been awarded with more than 20 projects, meaning about 35 million funding for all the partners. We just are catalyzers. We are working with different stakeholders, which are industries, research institutions, universities, or governments. That can be translated in the generation of about 120 new jobs, the different projects that we have been awarded in the last time. The project goes from subjects like desalination in the Micronesian region, in the island of the Atlantic. It goes about the user uptake of the Copernicus ESA European Union satellites, project to detect plastic on the ocean from satellites, Mission Atlantic, which is to study ecosystem, and Astral for the optimization of agriculture. We have projects for climate-ocean interaction like zero cost, project of ESA for ports of future to design port activity which are environmental, very clean. And we have two important projects with consortia with MIT and with UT Austin in the United States. One is called Magal and Aeros for the development of a small satellite constellation for purposes. We also have running several projects of ESA, the European Space Agency, for offshore wind energy and Atlantic cities. And in addition, we have a project to monitor air and water quality during the COVID pandemic to see what has been the evolution of those parameters. Those are normal projects that we are running. As I said, we already started more than 20 projects with different stakeholders in the different countries. But we also look for long-term infrastructure and long-term flagship projects. For that, the first exercise we did with our partners along the Atlantic is to detect what are the user needs. The user needs are very large. We need to protect bays and estuaries. We need to do analysis of coastal erosion, to protect fish stock, optimize agriculture, detection of oil spills, disaster monitoring, like tsunami, a large amount of user needs. For those user needs, we envisage a framework, which is going to be the framework to tackle and to help solving those problems. We call it APOS. APOS stands for Atlantic pole-to-pole observation system of systems. Well, system of systems because a single system cannot provide solution to all those needs. A pole-to-pole because the Atlantic is a unique system. Everything which happens in the Arctic will have an impact in the Antarctic. We cannot separate zones, and everything is a single unit. The architecture of this APOS framework is composed of 7 main parts. We have a space component, which is very important because space gives synoptic measurements. We have an atmospheric component with drones and high-altitude platforms, but we need data from the water. We need sea surface data from vessels, from voyages, but also the water column. We need gliders, and we need CTDs to get all data from the bottom of the sea out to the outer space. Only the fusion of all these data is able to give us probability to solve or to mitigate the problem we're dealing with. We have a common control center and a big data component where we store all the data with big data science algorithm. And the most important part is the users. We make this available to all the users, to all the countries in our organization, so that using artificial intelligence, using mathematical models, they can develop the solutions. At the end, we really want solutions for biodiversity, coastal erosion, or fisheries. Well, this, as I said, we're using many different types of satellites, the Sentinels from the European Union, we're using NOAA, NASA satellites, but we detected a gap. We need ocean, very frequent data from many types of application, and that can only be achieved through a constellation. Then we are promoting a constellation called Atlantic Constellation. It consists on 16 satellites. Those 16 satellites will provide unprecedented frequent measurement of the Atlantic, in fact, all around the world. It's not only limited to the Atlantic by the way it is designed. And this constellation is to be done in collaboration with the Portuguese Space Agency, with the ESA, with the European Space Agency, but also with other countries. Up to now, 8 countries have shown interest on that, which is Brazil and Mexico in America, South Africa, Nigeria in Africa, and Portugal, Spain, Norway, and UK. That means this is one of our main flagship projects for the next future. Well, in addition of projects, we are dealing, everything is, people must be in the center. We need to close the gap with the society, and we need to get these people. For that, we open a scholarship program. We have opened a program of 60 PhD scholarships in international collaboration with universities of different continents. We opened the first 13 dealing with health, marine robotics, marine litter, numerical modeling. For us, that's important, to get to the people and putting the people in the center. And another activity, another important line is network events. We are living in the pandemic, and more than ever, we need to keep our network connected. The only way to keep it connected is through very frequent events. We are organizing what we call Networking Fridays. We started last year, and it's a very popular event. Every Friday, there is an expert which make a presentation on Atlantic issues, and it is very popular. We got people from over 120 countries, and thousands of people connect either by YouTube or by our direct channel. This is today a very popular event that helps us to keep all the community at the Atlantic connected. We do also high-level meetings, and in fact, Greg, who is doing the previous presentation, he was organizer of the 6th high-level dialogue on the Atlantic interaction in Philadelphia, with the participation of 11 ministers, 700 registered participants, and 70 speakers, that help us, again, to keep the commitment of the governments and to keep people connected. We do also important events on blue economy in Bahia, in Brazil, and in the Amazonia. We are going to open the Air Center office in Amazonia in the next weeks. And for the future events, we are co-organizing the All-Atlantic Meeting 2021. This is going to be held in Azure Island in Ponta Delgada, June 3rd and 4th. And this is one of the events organized by the Portuguese presidency of the European Union. In addition, on the following week, on June 10th, 11th, we are organizing the European African Summit on Earth Observation, so that we can join the effort of the 2 continents for Earth observation towards a greener and digital Atlantic. And this year, the high-level meeting is supposed to be in Cape Town by the end of the year. Well, as conclusion, the Earth Center is an international tool to develop to help for a digital and greener Atlantic. We move in many lines of activity. We have set up infrastructure of the Earth Observation Laboratory, Marine Biodiversity Observation Network, geodesy. We start leading more than 20 projects in the different domains of sustainability. And eventually, we want to keep the people in the center by networking events and by big scholarship programs. Thank you very much for your attention.
Contribution here in this panel of speakers. Thank you so much. Time now, and I invite you to stay with us because the audience has some questions to see answered by you. So we start by Joana. Are you listening to me, Joana? Yes?
Yes, I am.
Yes, we have a question, a long question here. We can say that innovation or National Innovation Agency is the Ministry of Science's operational arm to support the funding of research. What is the balance for the current Horizon 2020 program and the expectations for the future European Research and Innovation Program, Horizon Europe, in terms of the breeding of climate and space data and give continuation to running projects and initiatives?
Well, first I should say that actually the Innovation Agency is in the intersection between the science and the economy ministers. In fact, it answers to both of them. And actually our mission is precisely to link different stakeholders to foster innovation. And now, as regards to the future programs, naturally we will, in the lines of what we have been doing, we will continue the work, but also addressing the challenges that we have ahead, not just in climate change, but of course the large economic and social challenges that we are facing currently, always keeping in mind the path to carbon neutrality.
Joana. Jessika.
Yes.
Jessika Trancik, we have a question from our audience. You and your team dedicate to using data and creating models towards solutions to accelerate achieving climate challenges. Which are these, or which are the areas, services, or institutions that can more swiftly use and benefit from your work to create the aimed impact to diminish CO2 emissions?
Yeah, thank you. Yeah, so really what we see is that innovation in the technologies that have improved, so those include solar energy, lithium-ion battery technologies are now enabling many more people to adopt electric vehicles. Wind energy costs have come down. These are some of the examples of technologies that have improved. And in these cases, what we see is that there were many different contributions from different parts of society to these changes. There were government policies that created markets around the world and also funding for research. And then there were people working on manufacturing lines in research labs, the public that decided to adopt some of these technologies, some of the early adopters, and people working on improving installations in the field. So consequently, the research that we do addresses just at all of these levels. It really depends on the technology that you're talking about. So in the case of electric vehicle charging, for example, the results that I presented can I see them informing decisions, for example, in the US and in many other countries. There are very ambitious goals to electrify transportation. These results can inform how the incentives are set up for innovation in electric vehicle chargers. And as well, businesses, and we work with companies, they can then use the results to plan ahead and make their own announcements for how they're going to be installing charging infrastructure. So that's just one example. In the case of stationary storage, what I see is a number of startups have taken on the cost targets that we mentioned. And so that's kind of a benchmark that they're working toward. In the case of setting emissions targets, understanding this process of how technology evolves and how some of the technology areas where we haven't been as good and ones where there has been success. I think this is informing emissions targets that are being set and sort of pathways to reducing emissions. So I intentionally set up the research so that it can address the critical decision makers across all of the important innovation challenges that remain in drawing down emissions to net zero emissions globally.
We have another question from John Lindberg. If externalities such as improved transmission are required to move to renewable energy sources, shouldn't these externalities, it's hard for me to say this, be included when evaluating the costs of renewable sources?
What question you're answering, but if you are asking whether renewable energy is cost competitive with other sources of energy or electricity specifically, then we have to then answer a number of sub-questions. We have to say, what is the level of renewable adoption that you're talking about? If it's a small amount, then something like looking at the levelized cost of energy and sort of using the existing transmission and distribution infrastructure is a good metric. So looking at just the cost of, the full total cost of owning and operating the solar or wind plant. Now, once we start getting to, 50% of power coming from renewables and above, that's when you need to start thinking about the system upgrades. And depending on the location where you are, it may be less than 50 or more than 50. And then you need to be thinking about, okay, what are the costs of reliably providing power with that source? And as I mentioned, that can be done through installing energy storage. It can also be done through demand management, which is a fabulous approach because anytime you can avoid physical infrastructure and instead use knowledge and responses in terms of behavior, it's better because you're going to have less negative consequences from that as long as these systems are set up with considering equity and sort of considering people's well-being, but that's another approach. And then also transmission infrastructure expansion, particularly we're talking about large continental masses. This can also help to balance renewables. So yes, we need to be very specific about what question we're asking, what decisions the research will inform, and then consequently do the cost analysis based on that.
Thank you. Now a question for Ricardo Conde. Technology and knowledge together with quality data is a highlight from your presentation. As you rightly quoted António Guterres, there is no planet B. So how do you see the contribution of the Portuguese infrastructures being created in our Azores island to mitigate the impact on climate change and environmental disruptions?
Well, this is a good question, but I can say that we cannot look only to infrastructures that create a big impact. This is overall synergies and critical mass of knowledge, infrastructures to act all together on that. I think if we look to the Portuguese initiatives, we are addressing what we call the digital planet, which is a platform to have this multi-Earth observation data, but coming, of course, from the satellite constellations that we are promoting as part of the answer for this, to answer this challenge, and also all the operational infrastructures that we are also preparing. So our main objective is to look as a whole in the upstream, and the middle stream and downstream, and particularly fostering the downstream applications. So a source, and particularly what we are promoting in a source, is a key point of interest, because we are not only promoting the upstream with us initiatives for access to space, also to build, and part of our value chain for the Atlantic constellation, to build this network of satellites, but also to create the value chain with the downstream application development, this application to have more data, more accessible data, remove the barriers, as I said, but particularly to create new policies for data. So this is a completely chain, not particular one infrastructures, but combining all the what we call here the programmatic challenge that we are implementing at the national level.
Thank you so much. And now for Isabel, a question from Carlos from the audience. Since most of sources of data are distributed and not much correlated in results, can we rely on these separated data sources? And what is the future of open data management?
These are two questions. Well, first one about consistency of the data and different data sources. That is the work that we have been doing and that we will continue to do to ensure or to verify whether they are consistent, and if not, how, in which way they are not consistent, and then how can we bring these data to form a consistent data set. In the case of the data that we are already providing, that work has been done, so we have ensured that all chain will provide a consistent set of various variables that we call these data cubes. And these data, they are all freely available. To use them, it requires eventually some effort. We have been putting our priorities in getting very high quality data. Now we are also ensuring or trying to ensure that these data can be easily assessed and used by the general public. But I would even see that there's an opportunity for other players and even the private sector to serve as an intermediate between agencies that are, providing this full range and very heavy data to bring these to the general audience. I would say there's all opportunity for the private sector there as well.
Thank you, Isabella. Now for Gregory, I have two questions from our audience. First of all, do you want to answer the first one and I'll do the second one? Or do you want to hear the two questions and you answer both? What do you prefer, Gregory?
How about we try to answer both because of time?
Okay, thank you. That's a nice thought. Thank you so much. So the two questions are, first, climate change is transversal and affects the world population and could be in fact done to make sure we are fair and solutions reach all in a democratic way. And the second one is, I believe you were responsible for a very important event directed to the need for more policy initiatives and guidance related to climate. Do you like to share main conclusions?
This in a different way, and I believe that the Atlantic is starting place because we have all of the countries connected. They're all going to be impacted by climate change. All need to work together. We all need to build up capacity where there isn't enough. And we need to do that as democratically as possible. In terms of my initiatives, ongoing, I am working all the time trying to bring more people to use data. We use the Copernicus data, for example, during COVID, and I think that's where my efforts will remain, how to bring more people into the game to use the data on the ground. Thank you.
Thank you, Gregory. And now, finally, Miguel. We have a comment and a question. The comment first is Manfred that says, the south of Portugal, Algarve, was covered some weeks ago by the dust and sand originating in enormous sandstorms in West Africa, a significant Atlantic scale problem. And the question is, for Portugal and the Atlantic countries, space and climate solutions are fundamental. Could you comment this particular saying that, in fact, that's something that happened in south of Portugal had an enormous impact in Africa, right? An Atlantic scale problem. We are all united. So.
This is something we discuss when we talk about pole to pole, because everything is highly connected. This event, which happens a few days ago, which can be seen very well by satellite, it's more frequent in Madeira and Canary Islands. That happened with high frequency. But it has an impact. Even this dust may even reach America. And there are some events like Sargassum, which start in the coast of the Atlantic and can go to the coast of the Atlantic. I mean, this is interconnected. That's why we need international collaboration. It's not the endeavor as a single country to deal with those problems. That's our goal on the Earth Center. Is to join the different countries, because this is a common problem, and we can only solve that together. And not only international, but also multidiscipline. This is not just by space. Space is one of the components, but we need oceanographers. We need the data from the bottom of the sea. I mean, we need multidisciplines, and we need international collaboration.
Thank you, Miguel. Thank you to all our speakers. I remember that space can even give us the data, the information, and the large perspective that we need to mitigate climatic changes. The next years are an enormous challenge for scientists, investigators, but also politicians. Tomorrow morning, we'll be back to talk about resilience, adaptation, and the mitigation solutions, new business models, and the young generation's intervention. Thank you to all our speakers. We can see, or still see, this incredible image of our planet, of our house, from the International Space. It's unbelievable. It's the best way to close this first part of the day. So I remember, tomorrow morning we'll be back. Thank you to all our speakers, to all the audience that was all over the world paying attention. See you tomorrow. Come back, please. Thank you.